Hi, this is Brian Kim. I'm going to share with you this case of a patient with a moderately dense lens and a posterior plaque, as well as some weak zonules. You're going to see double chop, cross chop mechanical fracturing techniques and show you how I systematically break down this lens. And I'll be doing this with the 2.4 millimeter incision. So first things first, I don't like to have any exposed lashes on my field. So I cut those and then flush the surface of the eye liberally to make sure we get rid of those lashes as well as any oil on the surface of the eye. And in this case, I still see some lashes, so I'm going to actually redrape, remove the speculum, use a cotton tip to roll the lashes out, do that rolling technique, and then place the speculum in again. And when I do it this way, I'm able to really make sure that the lashes are completely out of the way. And once the lashes are out of the way, go ahead and place the speculum back in, and then just really liberally remove the oil on the surface of the eye with a flush of the BSS. So I use a cotton tip to steady the eye and a corneal marker, which will help me to center and size my rhexis. I make a paracentesis incision first on the right side, and then eventually on the left side. I make the incision parallel to the iris plane, which creates a nice corneal shelf, which will enable me to achieve a self-sealing corneal incision. You can see the dense posterior plaque on this patient. Inject some intracameral lidocaine and then some dispersive viscoelastic to fill the anterior chamber and flatten the anterior capsule. This is kind of a bibevel technique using the metal blade. I go near to the limbus into the cornea, stab, and then tilt. By tilting it, making it parallel to the cornea surface, I'm able to tunnel through the cornea. Once I get to that mark, I turn the eye towards me and then enter using the cannula to help me. As I'm switching to the rhexis forceps, I'm pushing more viscoelastic to fill the anterior chamber, which I feel gives me a lot more confidence that I'll be able to have a rhexis that doesn't want to radialize. I punch through the central capsule, hold downward, and then grasp the right side of the tear to create a flap, and I grab and re-grab as I go. And I really do feel, since I inject that extra amount of viscoelastic, my rhexis tends to not run out nearly as much as it used to. And so I do think that's really an advantageous, simple step to do. So I finished the rhexis in purple viscoelastic. This is a capsulorhexis hydrodissection technique. I place the cannula out to the equator contra-incisionally, pointed tip down, get a nice fluid wave, decompress the bag on the left side, pointed tip down on the right, and the lens begins to spin quite nicely. Now it's time for the phaco. I'm adjusting the tip. Irrigate the surface of the cornea. Lift the incision with the chopper, go in with irrigation off to minimize Descemet's trauma. Remove the surface epinuclear material. Place the chopper underneath the epinuclear ridge out to the equator. Point the phaco tip vertically subincisionally. Bring the instruments together, crush it, and divide the lens completely in half. That's the double chop. Place the chopper around the right heminucleus, pull it centrally towards the phaco tip, crushing and dividing the right heminucleus. That's the cross chop. Using a little bit of vacuum to lift that first quadrant up, and then placing the chopper around it, crushing it against the phaco tip, and then emulsifying the lens pieces. Pulling up that piece up with the phaco tip, and then once it's on the tip, crushing it with the chopper and emulsifying the lens pieces. Place the chopper around the second quadrant, pulling it centrally, dividing it, grabbing it with a little bit of vacuum from the phaco tip, and then crushing it with the chopper, and then emulsifying the lens pieces. Placing the chopper around that piece of that second quadrant, prolapsing it up out of the bag, using a little bit of vacuum to hold it, and then crushing it with the chopper and emulsifying. Placing the second heminucleus in front of me, place the chopper around the lens, pulling it centrally towards the phaco tip, dividing the lens in half, using a little vacuum to pull that third quadrant up, placing the chopper around it, crushing it and dividing the lens piece into smaller pieces, successively crushing it into smaller pieces, and then emulsifying the lens pieces. Using a little bit of vacuum to grab the piece, and then crushing it with the chopper, making them smaller, and then emulsifying the lens pieces. This is the last quadrant, placing the chopper around the lens piece, placing the phaco tip deep, crushing it and dividing the lens piece, crushing the lens into smaller and smaller pieces with the chopper and phaco tip, and then emulsifying the lens pieces. So this is a final fragment. Place the chopper around it, pulling it up out of the bag, crushing it between the chopper and the phaco tip. You can see I'm even able to chop it against the side on the shaft of the phaco tip. It doesn't really matter how you crush it, as long as you use the phaco tip and the chopper to crush it. So remove the epinucleal material, take the chopper out, push BSS in, take the phaco tip out, and then go in with the INA handpiece. I'm adjusting the sleeve, bringing it closer to the tip. And then going subincisionally first, removing the cortex from anterior to posterior, sweeping side to side, which very gently teases the cortex off of the capsule, teasing with the side and side movements, and then mechanically lifting it and teasing it off. I like to do it this way rather than going pedal to the metal with a vacuum, because if you go too high vacuum, you might grasp the capsule or something like that. Switch to the polish mode, starting to polish underneath the rhexis edge, removing lens epithelial cells. Removing some fine wispy material attached to the posterior capsule. You see, as I did that, it does cause some puckering of the posterior capsule, which does tell me that the zonules are a little bit weak in this case. Again, this is a dense lens. I usually associate dense lenses with weaker zonules, so oftentimes I do pick a three-piece lens in these situations, because if there is any long-term late instability to the bag, I can lasso a suture around the three-piece haptics. Place a BSS cannula through the paracentesis. Place it under the rhexis edge subincisionally. Start pulsing BSS into that space. Thankfully, there is no lens material that I saw there. And then I'm injecting some viscoelastic, cohesive viscoelastic to fill the bag. And then I'm going to use a sweep to start to polish underneath the rhexis edge on the left side first to remove any lens epithelial adhesions from the rhexis edge. And then polishing on the right side. Since this is a three-piece lens, this is a 2.4 millimeter incision, I have to widen the incision with the paracentesis blade. And then this is the three-piece intraocular lens. Turn the barrel to the left. As the lens is delivered, the leading haptic comes out planar, goes into the bag. As the optic is delivered, I rotate the barrel 90 degrees counterclockwise so the optic comes out flat. And then I'm using the Maltzman to gently tease the trailing haptic into the bag. I go in with irrigation off, activate irrigation, go underneath the optic, remove all the viscoelastic from within the bag and underneath the lens. I switch to the polish mode and start polishing underneath the rhexis edge some more, because with this manipulation, this does cause a little bit of that lens material to be stuck between the lens and the capsule. And then I remove the viscoelastic from the anterior chamber. So again, this is a 2.4 millimeter incision. You can see the technique is essentially the same from my other incision, which was 2.6. I'm able to perform double chop, cross chop mechanical fracturing techniques to systematically disassemble this lens and using ultrasonic energy sparingly. You can see, even though I made the rhexis round, you can see slight ovalization of the rhexis here. And I do believe that is because of the tension from the zonules in the bag. That's why I do prefer a 3-piece lens in these situations. Double chop, cross chop, and mechanical fracturing provides a lot of advantages, especially in these cases where there's a dense lens and weak zonules. By very carefully crushing the lens into smaller pieces and emulsifying the lens pieces once they're smaller, you use less energy and less vacuum, which is always, in my opinion, the safe way to go. So I hope this was helpful to you, and I thank you for your attention.